Have you ever wondered how computers understand our instructions? Well, it all begins with the magic of programming languages. These are formal systems, carefully crafted to instruct computers. They act as a bridge, enabling us to communicate our ideas to a machine in a language it can understand and execute. Each programming language carries its unique syntax and semantics, much like the diverse human languages we speak every day. And just like those languages, different programming tools are suited for different tasks. Some yield low-level access to memory, while others make it possible to run the same code on various platforms. Some are known for their simplicity and readability, others for enabling interactive web pages. From system programming to web development, game creation to data analysis, there's a programming language for every digital task you can imagine. So let's dive in and learn about some of the key programming languages and how they help us interact with our digital world. First off, we have C. A cornerstone in the world of programming languages, C is hailed for its procedural nature. This means that it follows a top-down approach, with programs being broken down into procedures or functions. But what really sets C apart is its efficiency. It allows for low-level access to memory, which can be a powerful tool in the right hands. This direct control of the hardware makes C a go-to choice for system programming. When we talk about system programming, we mean developing operating systems, compilers, network drivers, and the like. It's all about controlling hardware and resources. And C is quite adept at this. Additionally, C is also frequently used in developing other programming languages. It's like the grandparent of the programming family, laying down the groundwork for its descendants. Even languages like Java and Python owe their existence to C. C has set a strong foundation for many other languages that came after it. Next up is Java. Known for its object-oriented nature, Java is a language that has made a significant impact in the world of programming. It's a language that's all about creating and manipulating objects, making it a perfect fit for complex software systems and applications. Java's portability is another hallmark of its design. It was built with a write-once-run-anywhere approach. This means that Java code, once written and compiled, can be run on any platform that supports Java without any need for recompilation. This level of portability is a game-changer, allowing developers to create software that can be used across a wide range of devices and operating systems. This versatility has made Java a popular choice for web development and enterprise applications. Its robustness, ease of use, and cross-platform capabilities have made it a go-to choice for many developers working on large-scale, complex projects. Java's write-once-run-anywhere principle makes it a go-to choice for many developers. Now, let's talk about Python. Python, a high-level programming language, is celebrated for its readability and simplicity. It is designed with a philosophy that emphasizes the importance of programmer effort over computer effort. With its clean, English-like syntax, Python is extremely easy to read and learn, making it a fantastic choice for beginners and experts alike. Python is dynamically typed, meaning you don't have to declare the data type of a variable when you create it. This provides significant flexibility and speeds up the coding process. However, it also places a greater emphasis on testing to catch any type-related errors. Python's simplicity doesn't limit its power. It's widely used in a range of applications, from web development to data analysis, artificial intelligence to scripting. It's the language of choice for many tech giants, including Google and NASA. Python's simplicity has led to its widespread adoption in a variety of fields. It's a testament to the fact that sometimes less really is more. Next, we come to JavaScript. In the sphere of web development, JavaScript reigns supreme. It's the magician behind the curtain, enabling the interactivity, responsiveness, and dynamism that we've come to expect from modern web pages. From drop-down menus to image sliders, JavaScript brings web pages to life, transforming static HTML and CSS into something far more engaging and user-friendly. But JavaScript's influence extends beyond front-end development. With the advent of Node.js, JavaScript broke free from the confines of the browser. Now it's making waves in server-side development, powering web servers and application backends with the same flexibility and dynamism it's known for in the browser. JavaScript's ascent in the world of web development has been nothing short of meteoric. Its role in enabling interactive web pages, its extensive use in front-end development, and its growing popularity on the server side has solidified its position in the developer's toolkit. JavaScript's versatility has made it a staple in web development. Moving on to C++. This language is essentially an extension of C, but with an added twist. It includes object-oriented features. Object-oriented programming, or OOP, is a paradigm that allows for more organized and modular coding. It's like having a blueprint for creating similar objects with the same properties and behaviors. This is particularly useful in large projects where code can be reused, making development more efficient. Now, where does C++ shine? Well, it's widely used in game development, systems programming, and performance-critical applications. In game development, C++ is a superstar. It provides a high degree of control over system resources and memory, which is essential in games where performance is critical. Additionally, its support for OOP makes managing and manipulating game entities a breeze. And it's not just games. C++ is also prevalent in systems programming due to its efficiency and direct access to hardware resources. And for performance-critical applications, C++ low-level capabilities allow for optimized, speedy software. C++ power and flexibility have made it a favorite among game developers. Let's discuss Ruby. Ruby is a dynamic, object-oriented programming language. Its design philosophy revolves around the idea that programming should be fun and flexible, allowing for multiple ways to do the same thing. This approach makes Ruby highly readable, simple, and more productive, often leading to aha moments when you realize just how straightforward something can be. Ruby shines in the realm of web development, largely thanks to the Ruby on Rails framework. Ruby on Rails, or simply Rails, is a server-side web application framework that provides a default structure for a database, a web service, and web pages. It encourages and facilitates the use of web standards such as JSON or XML for data transfer, and HTML, CSS, and JavaScript for user interfacing. In essence, Ruby and Rails together offer a full-stack web development solution, meaning you can build everything from the back-end logic to the front-end aesthetics. Ruby's elegance and productivity have made it popular for web development. Now let's talk about Swift. Swift, unlike the wind, doesn't just breeze through. It whizzes with purpose and precision. Crafted by the tech giant Apple, Swift is a statically typed language, meaning that the type of a variable is known at compile time. This adds a layer of safety and can help catch errors before your code even runs. Swift is like the Swiss Army knife of Apple development. Whether we're talking about creating an app for your iPhone, designing a stunning interface for a Mac, or even developing software for your Apple Watch or Apple TV, Swift is the go-to language. It's been specially designed for these platforms after all. But what makes Swift stand out in the crowd? It's fast, like its name suggests. It's modern, embracing the best of recent language trends. And it's safe, designed to eliminate entire categories of common programming errors. Swift's speed, modernity, and safety make it a prime choice for Apple developers. Finally, we have Go, or Golang. Born out of Google's need for efficient, easy-to-use programming, Go has made a significant splash in the world of coding. Its simplicity is its secret weapon. With a syntax that's clean and straightforward, Go reduces the cognitive load on the programmer, allowing for a focus on problem-solving rather than wrestling with complex language constructs. Go also shines in its efficiency. With a strong emphasis on performance, it delivers speed that's comparable to languages like C or C++, but with the ease of use typically associated with higher-level languages. Furthermore, Go has robust support for concurrent programming. This means it's well-equipped to handle multiple tasks at the same time, making it ideal for modern multi-core processors. Its power and simplicity have led to its widespread use in creating system tools and web servers. Go's simplicity and efficiency have made it a rising star in the programming world. Now that we know about programming languages, let's talk about compilers. A compiler is like a translator, converting the code we write into a language that our computer can understand. This translation is not as simple as swapping one word for another. It's a multi-step process. First, the compiler performs lexical analysis, breaking down the source code into tokens. Then it conducts syntax analysis, building an abstract syntax tree to understand the program's structure. The next phase is semantic analysis, where the compiler checks for errors and ensures the code follows the language's rules. After this, the compiler generates an intermediate code, easier to optimize and potentially platform independent. It then optimizes this code to improve efficiency and speed before finally generating the machine or assembly code. Examples of common compilers include GCC for C and C++, Java compiler for Java, and Python's interpreter. Compilers are the bridge that connects our human-friendly code to machine executable instructions.